Yes, guys. So we are doing question number 8 here. Okay. So the question number 8, a quadrant of a circle of radius A. This quadrant of a circle of radius A revolved about a line about the chord AB. It says about its chord. Then show that the volume of the spindle generated is pi upon 6 under root 2 into 10 minus 3 pi into A cube, A whole cube. This is A cube here. Okay, so this we have to show here that the result is this. What is the question here? That this quadrant or this arc of this circle is revolved about the line AB, which is chord of the circle here, about its chord. Whenever we apply this formula, the formula for finding the volume of a solid generated, in case when an arc or any curve is revolved about a line which is other than the axis, then we use the formula pi into Pn square, where Pn is the perpendicular drop from the point P on the arc to the line about which we have to revolve it. Okay, so this is the line, AB is the chord, the line about which we have to revolve this. Okay, so this is the point here. So Pn is the perpendicular length, perpendicular distance of the line AB from the point P. So this we have calculated here. Pn is perpendicular length from P to AB, which is calculated like this, because equation of the line AB is x upon A plus y upon A equal to 1 by intersect form. This is A length, this is A, because this is radius. A is the A is the radius of the circle here, which is given to us. We have just drawn the circle, but we have to just find out only this arc will solid generated by this arc about this line AB, which is chord of the circle. So Pn is the length of P. Okay, the length from P to AB, length of the perpendicular or perpendicular length from P to AB. This is given by this A into x1 or x1 into A plus y1 into B minus C divided by under root A square plus B square, where A and B are coefficient of x and y. Coefficient of x and y are 1 and 1. So this is x plus y minus A upon under root 2. So we can write it as x plus y minus A upon root 2. This 1 plus 1. Okay, so this is the length Pn. Now what is An? Now we have to find out. Why An? Now An, in this right triangle A and P, we have An square is equal to AP square minus Pn square. Pn we have just calculated. What is AP here? AP is the length between or distance between 2 points. First point is this xy. Let me take xy, and this is A0, because the point at the at the vertex of this point or on the end of the circle, this is radius A. So this is A x coordinate, by is 0 coordinate on the axis of x. This is axis of x here. Okay, so now let me find out what is then AP. So AP is nothing but x minus x1 whole square, that means x minus A whole square, plus y minus 0 whole square, that means y square only. Okay, this is length AP. What is Pn here? Pn is this value. This is x plus y minus A upon root 2 whole square. Let me solve it further. It will give us x minus A whole square plus y square here, minus this is nothing but x plus y, minus A upon root 2 whole square. If I solve it, this is square root 2, so square of this will give us 2 only. So 2, if I take outside 1.2, this is twice into x minus A whole square plus twice y square, this multiplying by 2 here, because taking LCM, 2 is the LCM in this case. Taking 1.2 outside, now LCM are not right here. What is the whole square of this value? Now whole square of this x plus y minus A whole square is x square plus y square plus A square, that we write. Then minus twice AX minus twice AY plus x into y twice xy. This is the whole value. Okay, now further let me solve it. Twice multiplied. First let me open this whole square. So it will give us twice x square plus a square minus twice ax plus 2y square minus sign. If I open this whole, this is minus x square minus y square minus a square. This is plus twice ax plus twice ay minus twice xy. This whole value. Now let me further solve it. This is twice x square and x square. This is x square only. Twice a square minus a square is plus a square only. And twice y square and this y square is plus y square only. Okay. And this is minus twice a, sorry, 2 to the 4, 4ax minus 4ax and this plus 2ax, which is minus twice ax. Then what are the leftover values? These values are left over. This is plus twice ay minus twice xy. Now what is whole square? Now this is something, whole square of something. Now here these two values are negative, y is positive. Okay, so it means a by must be negative. It can be written as 1.2. In bracket, if I write it as x minus a minus y whole square. Now this is whole square here. Why? So if I open this x minus a minus y or x minus y minus a whole square, then we will get this whole value, because x square plus a square plus y square, all right. Then minus twice ax plus twice ay, which is twice ay positive, okay, and minus 2xy, all right. This is the value here. Therefore, an is equal to, therefore, this is value of an square. So an is equal to, therefore, 1.2. This is 1.2, and the square root of, or sorry, this value, the square root is, and the square cancel out. So this is only x minus a minus y here. Okay, so this will give us, let me now write here. Therefore, an is calculated. What is an here? An is 1.2 into, this is x minus y minus a whole square. Sorry, only whole square is cancelled out. This is length of an. Now, if I have to find out differentiation of this with respect to x, why? Because the volume is to be calculated. What the volume of this value? That will be, let me first find out volume is what. The volume of the solid generated by revolution of arc AB. Arc AB or APB, let me write here. This is APB about the chord AB. About the chord AB. That volume we have to find out. That volume is given by, here limits are, in this case, x limits is 0 to a. So limits for, or b to a, what are the limits for b to a? Here x is 0, here x is a. So limits are 0 to a. This is x equal to 0 to a. And this is pi into pn square. Try to understand. This is pn square. Or let me write here pn square into dan. This we know about. Now dan can be written as, this is 0 to a pi into pn square, okay, into dan into dx divided by dx, okay. We have to differentiate an with respect to x. What is differentiation of this? Let me write that value here. So further, let me now solve it here. Therefore, here an can be further resolved. What is an? So 1.2, and this is nothing but x minus y is from this equation, from first equation. Y square is equal to a square minus x square, or y is equal to under root of a square minus x square. We have placed the value of y here. Y is from this equation. Y square is a square minus x square from first. Therefore, y is equal to under root of a square minus x square minus a here. Now I have to find out ddx of this. an, ddx of an, differentiation of an, so this is 1.2 constant value, x is 1 here, this is minus sign, but from this differentiation will come first 1.2, okay, as it is, this is a square minus x square whole power minus half, okay, into minus 2x, differentiation of x square again, this is minus twice x here, okay, so that, and minus a is 0, so that will give us, let me now write here, what is the final value of ddx of an, ddx of an is 1.2, it is 1x differentiated by 1, minus minus plus here, 2 to cancel out, it is nothing but x upon under root a square minus x square, this is the value of 1.2, sorry, ddx of an, this value is. Now let me write it here. So what is the final, I mean this value if I substitute, so an was, sorry, pn was x plus a, x plus y minus a upon under root 2 whole square, this value was, therefore let me write here, therefore volume, okay, let me write here, therefore volume is equal to pi, let me take outside, 0 to a limits, and this pn square, let me write here, pn square into ddx of an into dx. So this we are writing here, pi 0 to a, pn square is, we calculated here pn length as x plus y minus a upon under root 2, that was the value of pn, perpendicular length of p from on the line AB or from the line AB, that is the value, therefore this is nothing but x plus y minus a upon root 2 whole square, and this is ddx value, this is 1.2 into 1 plus x upon under root a square minus x square, okay, this is under root a square minus x square into dx now, okay, so this is the volume which we have to calculate, and finally we have to prove that this volume is equal to this value, okay, let me further solve it, this is pi 0 to a, this whole square, this is now 2, this is under root 2, let me take 2 root 2 outside, so pi 2 upon root 2 is outside, x plus y minus a whole square, and this is nothing but 1 plus x upon under root a square minus x square, this value is there, so let me change it. Okay, so this, if I open this whole square, let me open this whole square, pi upon 2 root 2, 0 to a, so this will give us x square plus y square plus a square plus here twice xy minus twice a x minus twice a y, okay, into 1 plus x upon under root a square minus x square into dx. Now if I just multiply this and then find out the values, so that will give us, after multiplication of this whole, that will give us, if we write pi upon 2 root 2, this is going to us 0 to a, this is a minus x whole square, this will come out as a minus x whole square, we will write here, then plus a square x, okay, there are 6 steps we will get here. If I just multiply by x upon under root a square minus x square to this, first by 1, then by x upon this, that whole value will give us something. First this a minus x whole square will come out, okay, a minus x whole square will come out, and plus a square x upon under root this, and this is plus a square, this is after simplification I am writing, a square x upon under root, this is a square minus x square minus a x square upon under root a square minus x square, okay, and then other two terms let me think about, okay, those values were coming out as Okay, minus this is a into x square upon under root a plus x under root this and minus, okay, that value there. So that is the two more terms are there, plus x under root a square minus x square and minus a under root a square minus x square within bracket into dx. So these five terms will come out a 1, 1, 2, 3, 4, 5. After simplification, multiplication of this whole will give us this value. This is on after simplification. This is after simplification. Now in this we can integrate this a minus x whole square by putting 0 to a limits, no problem. Okay, now if I integrate this whole, let me now further solve it. That will give us volume we are calculating of the solid generated by revolving this arc APB about the chord AB. We are calculating this V is equal to, this is pi upon, okay, 2 root 2, and now the first integration of this is minus a x whole cube upon 3. Why? So this is with respect to x. If I integrate this, it is a minus x whole cube upon 3, then minus x is again integrate, so this is minus 1 we have multiplied, plus in this we will put here, okay, and for this and this and this and others, putting x equal to a sin theta and dx will be a cos theta d theta. Try to understand what are the limits here, and the limits for these terms which are including under root a square minus x square, a square minus x square, for them only we are calculating. Okay, so for those values, let me now rub this one. For that limits are, if I put x equal to a upper limit, then it is 1, so sin theta will be pi by 2 at x equal to a, and theta equal to 0 at x equal to 0. So these are limits now 0 to a in this case. It will give us plus sign. Now here we have to apply the limits 0 to a only, because the first a minus x we are not changing any put, or we are not putting here anything, only limits 0 to a we will apply, and in these we have to apply putting x equal to a sin theta. In the first one what we get, this is plus a square. Now integration 0 to pi by 2 here, x is a sin theta, this is a sin theta, into dx is a cos theta d theta, and from the denominator we will get a square minus a square sin square theta. That means a will come out into cos theta, so this a cos theta cancel out. This is the first step. Minus sign, this is a x square sine of integration 0 to pi by 2. This is x square now. What is x square? We have got a square into sine square theta, okay, into a cos theta, divided by this this comes out to be a cos theta. A cos theta cancel out into d theta. Okay, this is, now let me rub this. This is the second, the third step, second, third, and this. Now these two left are over the next one. This is again limits x is here a sin theta into a cos theta will come out from under root. So this is a cos theta, and one a cos theta is in place of dx. So this is a cos theta d theta also, sine of integration 0 to pi by 2. This is the value. A cos theta has comes out twice because under root a square minus x square into dx. Dx is a cos theta d theta. Okay, this is the second last. Minus a, then other is a sin a cos theta. 2 a cos theta will come out now. A cos theta into a cos theta into d theta, sine of integration 0 to pi by 2. This is the whole value. This is integrated. Now after solution of this whole, let me further solve it. Now at a, it is now 0. Only at 0 it is plus sign, then it will be 0 at place of x, it will be aq upon 3. First value is volume we are calculating, this is pi upon 2 root 2. This whole value is, this is 1 upon aq upon 3 only, this value. But after putting 0 to a limits, or first a it is 0, a minus a 0, but at 0 it will be positive plus aq upon 3. Okay, then now this is plus aq here again, this is aq. Okay, this is now, let me further solve them. This is sine theta d theta only, 0 to pi by 2. Okay, so this plus sign, sorry, minus sign, this one minus a, what is the solution of this? 0 to pi by 2. This is now aq here again, this is a square and aq, and this is sine square theta into d theta. This is by shortcut formula we can apply this. This is 1.2 pi by 2. Okay, 1.2 pi by 2, we can take that, and this sine theta a or cos square theta. Second step is this we have taken, and this is plus aq, let me take outside. So this is sine theta into cos square theta d theta, 0 to pi by 2. Okay, so fourth step is this one is the final step, and this is minus again aq, aq 0 to pi by 2 into cos square theta d theta, cos square theta d theta. Now in this minus sine square, these are similar type. Why? Because cos square theta we can apply here what you call shortcut formula, and this is only sine theta cos theta, sorry, sine theta into cos square theta. So this whole value, if I just find out with the help of shortcut formula, in this case we can integrate this by cos theta minus cos theta, then apply 0 to pi by 2, it will be plus aq only. So it will give us, let me take pi aq outside, 2. This is 1.3 here, plus this is sine theta, you can integrate this as minus cos theta, let me take it as minus cos theta. Now 0 to pi by 2, at pi by 2 to 0 it is only 1, plus 1, because at 0 the value will be plus 1. This is plus 1 here. Okay, and then minus sine, this value sine square theta, that means minus, this will be 1.2 into pi by 2, whenever sine square theta is there, by reduction formula. This is by reduction formula here, minus pi by 2, and plus, here it is sine theta 1 power and sine cos square theta 1 power. It will be gamma by gamma function, gamma 1, because 1 plus 1, 2 upon 2, and gamma 3 by 2 cos square theta means 2 power, divided by twice gamma 1 plus 2, 3 plus 2, 5 by 2. This is therefore gamma. This is again reduction formula, minus this value is 1.2 into pi by 2. These two values are added up, minus pi only. For this pi by 4, pi by 2 it will be, minus pi by 2 it will be. Then this is plus 1 only. So after solving this whole value, I mean, what is the answer here? These are the values, 1, 2, 3, 4, and this one 5 we have taken. This is this one. Okay, this value is also there, 1, 2, 3, 4, 5. Finally, the same answer will be obtained. Let me just put it there. This is now pi aq upon 2 root 2. You are having this is 1.3 plus 1. This is 1 here. This is 1 here, and it is giving us pi by 4 and pi by 4. This is minus pi by 2 here, got 2 pi by 4, 8 pi by 2, and this value is there. This value is also there. Then it will give us plus sign. Gamma 1 is 1, gamma 3 by 2, let me write same, and in the denominator we are having 2 into 3 by 2 into gamma 3 by 2, gamma 3 by 2 cancel out, 2 to cancel out, 1.3 is there. Okay, so that is there, pi a cube upon 2 root 2. This is 1.3, this is also 1.3 here. This is 2 by 3 plus 1, 3 plus 2, 5 by 2 minus 5 by 2 here. Alright, that will give us the final answer. Now let me further solve it. So it is giving us here pi a cube upon 2 root 2. In bracket it is 5 by 3 plus it is minus pi by 2 here. If I take 6 out, or this is 3 to just 6, that will be, this 2 is coming, I'm sorry, this 2 is not coming here. This 2 is eliminated in the further one. 6 if I take LCM, is pi a cube upon 6 I will take here, and the outside upon root 2, 6 root 2 here. And this is 10 here, minus it will be 3 pi into a cube, this a cube is there. So it is the same value, pi upon 6 under root 2. This 2 was coming, but that 2 is not there because this is only pi a cube upon root 2 only. Okay, so this 6 has come out from inside. There is mistake of this 2, correct this mistake, but this is the same answer we have obtained. Pi by 6 root 2, 10 minus 3 pi into a cube is this. Okay, so a cube I have taken before the bracket, it is given in the after bracket. So this hence proved the same answer is obtained. Okay, so this is the volume generated by revolving this arc AQP, a quarter of this circle, about its chord AB. So that's the volume okay, of the solid generator is this. The same value is obtained. This is question number 8 we have done. Now let me talk about 9th question. What is question number 9? Let me check it. Okay, now question number 9 is of what kind? Let me check it. Okay, now question number 9 here. Question number 9, what does it say? Now it says, find the area of the surface swept out by the arc of the rectangular hyperbola. Okay. X square minus y square. Here we are given x square minus y square equal to a square. This implies that x square upon a square minus y square upon a square equal to 1. This is the hyperbola. Equation of the hyperbola we are given. Okay. Now it says, find the area of the surface swept out by the arc of the rectangular hyperbola. This x square minus y square equal to a square, extending from, what is the arc? Extending from, that arc extends from the vertex to the end of the lattice rectum. Okay. When rotated through 4 right angles. So that is the, let me draw the, here it is one of the arc of the, one of the part of the hyperbola we take. This is the hyperbola here. This we draw. Now in this case, now it says that arc is, this is the arc obtained. It says find the area of the surface swept out by the arc. This arc is between the vertex and the lattice rectum point, one end of the lattice rectum. Let me take, this is the lattice rectum L, this is A point, or let me take here A point, this is B point here, and this is L dash, this is lattice rectum. Now in this lattice rectum, we know that if the hyperbola is, this is equation number 1, and this is L point here. What is the point of this? We know that this is AE and L is B square upon A. Try to understand. This is AE, because point on the lattice rectum at this point is AE, this is AE, and b square upon a square in case when hyperbola is given x square upon a square minus y square upon b square equal to 1. In that situation, the coordinates of this lattice rectum, one point on the arc on the hyperbola is a b square upon a. That's the point. Try to understand if the hyperbola is given this, and we know that b square is equal to a square and b square is equal to a square into e square minus 1 in case of hyperbola. But in case of ellipse, it is 1 minus e square. B square equal to a square into 1 minus e square in case of ellipse. But in case of hyperbola, it is e square minus e is greater than 1. Eccentricity is greater than 1 in case of hyperbola. So this is e square equal to a square into e square minus 1. But here b is equal to a or b square equal to a square. Why? Because this is a square here we are given. That means this a square equal to, this implies that a square equal to a square into e square minus 1. That means 1 is equal to e square minus 1 or e square equal to 2. That means e is equal to under root 2. This is square root 2. Value of e is here is square root 2. Therefore, these coordinates are, if we write the new coordinates of the lattice rectum, because this is the vertex here 0 0, this point is, so from 0 0 to this point. Okay, now this arc length is revolved about the axis of x here. It says find the area of the surface swept out by the arc of the rectangular hyperbola, this extending from the vertex to the end of the lattice rectum, to the end of the lattice rectum, from vertex to the lattice end of the lattice rectum. Okay, and that is rotated lattice rectum when rotated through 4 right angles about the axis of x. So this is axis of x here. About the axis of x, if I revolve this arc about this axis of x, for that limits will be 0 to AE. In this case, AE we will calculate e is under root 2. So this is a root 2. Now what are the new points of the lattice rectum? Let me take point here. This is L I have taken, L point. This is B point here. So what are the coordinates of L point? Let me find the solution. Solution here. The arc swept by this, they say surface swept out by the arc. The arc this is AL